I would like to present the speakers. Jerry Schnorr will be talking first, and as you can see, he has accomplished very much in his career, and I won't go through these point by point, but he's co-director of the Center for Regional Environmental Research at Iowa City, and a member of the National Academy of Engineering, an editor-in-chief of the Environmental Science and Technology, which I believe is the #1 journal in the world for environmental science. And he has written many publications and has many prizes and awards from other places. And Steve Gorham will be the second speaker. He's with the director of Climate Science Coalition of America. And he has been working for 30 years in environmental policy and engineering and energy issues. And he has his MBA from the University of Chicago and his MS in electrical engineering from Illinois. And he's the author of 2 books, Climatism. I won't go through all the titles. But anyway, Steve, I think the book, you have some book copies outside, and you will be available for book signing after? Yeah. Okay, so I won't take any more time. So Jerry, will you like to present?
Thanks, Bill. It's a pleasure to be here. Can you hear me? No? How about this one? Is that better? Okay. It's a pleasure to be here. I've worked with many people from the CEEE at University of Northern Iowa, including Bill Stigliani for many years. We worked together when he was at the National Research Council, when he was in YASA. That's the International Institute for Applied Systems Analysis in Luxembourg, Austria, and now, ever since then, in my role at the Center for Global and Regional Environmental Research at Iowa, and his role here in CEEE. So it's a great pleasure to be here and to talk about one of my favorite things, climate, and to try to tell you what I know about, what I've learned about the science of climate change. I'm not a climatologist. I apologize for that, but I am an engineer. I'm a chemical engineer and environmental engineer. I work closely with climatologists to run models of the effects on streams and soils and agriculture as a result of land use and climate change. So I'll try to tell you a little bit about what I've learned and why I've come to believe that climate change is a very serious problem. It is caused by humans, and it's something that we should take seriously and begin to act upon. I went to Iowa State University in chemical engineering, and when I graduated, if you were to tell me that we could change the entire planet Earth, this big blue marble that we're talking about today, I would have been a little skeptical, I think. Maybe the atmosphere, you know, if you look here, it's a really thin veneer. The mass isn't actually so great. Maybe the atmosphere, the top 100 kilometers or so, because we're 7.2 billion people with a gross world product that's increasing, doubling every few decades. Yeah, maybe we could change the atmosphere. Never would I have thought that we could possibly change the oceans. It's such a great thermal mass, but I'm going to show you data which indicates that indeed we are able to do that. The thing about climate change is that it's not any one series of data or measurements. Rather, it's a story. It's a story that becomes quite compelling when you consider the multiple lines of evidence. And just in this talk today alone, I will be using things from surface temperature, down borehole records, ocean temperature, pH, CO2, and so on and so on. And it's all of this massive amount of information that's coming from so many domains, which is going to, it's not a perfect story. There's uncertainties, to be sure, and I'll try to point out where some of those uncertainties are. But taken as a whole, for all these sets of data, all these lines of evidence, it's a very clear and compelling story that humans are the base of the temperature, the changes that we're seeing in climate today, and I'll show you why I think so. Of course, the basis is that we've been arguing. I've been taking students since 1992 to the big international meetings like the Real Earth Summit in 1992. And I've seen about 190 countries arguing for over 20 years, tooth and nail, about how to turn this curve upside down. And so for 20 years, we've been arguing about this and making very, very little progress. So it should at first give us some pause that we're unable to even make this come to a peak, let alone what it looks like we need to do, and that is a steep reduction off of this graph, maybe an 80% reduction in the next few decades. When you emit that many greenhouse gases, when you burn fossil fuel that's been stored in the Earth's crust for 340 million years, since the Carboniferous period, that's when the coal was first laid down, and you mine that, and you burn it, and you put it back into the atmosphere in maybe 200 or 300 years, that's just the blink of an eye in geologic time, of course you're going to change the atmosphere. It's a no-brainer. When you take something that's been stored for 300 million years and re-release it into the atmosphere in 300 years, of course you're going to change the atmosphere, and indeed we are. And if you went to the doctor and this were your blood gases, I submit that you'd be a little bit concerned. And this is our carbon dioxide in the atmosphere, and we should be a little bit concerned. We know for sure that that carbon dioxide is coming from humans. There's no debate about that. For one thing, it began at about the Industrial Revolution, when we really began to burn coal in earnest with the invention of the steam engine in the late 1700s, early 1800s. It started to increase. So A, the timing is right. B, the amount that's increasing each year, now about 3 parts per million each and every year, can be fully accounted for by our measured emissions, both measured from satellite data and measured from reporting areas. So A, the timing is right. B, the amount is right. We can fully account for the accumulation of carbon dioxide in the atmosphere based on how much we're emitting. It's about half of what we're emitting. C, the dynamics are right. We can look at the isotopic ratios. We know it's coming from the fossil fuels, some of which are as old as 300 million years old. And we can see it mixing from the northern hemisphere, where most of the industrialized countries are, to the southern hemisphere. The dynamics are right. Therefore, the carbon budget is out of sync. There's a lot of carbon moving around, to be sure. But roughly maybe 9 is due to humans, both deforestation and direct emissions. About 3 of that 9, we think, on net, are accumulating in the terrestrial environment. A grading forest, that's pretty uncertain. We really don't have a good handle on that globally. We have a better handle on this number. About 2 seem to be, of that 9, seem to be accumulating in the oceans and changing the ocean chemistry. More about that in a moment. And so the remainder is about 4 that's accumulating in the atmosphere. When I first came to the University of Iowa some years ago, and I had a slide similar to this, it was at about 725 billion metric tons of carbon dioxide in the atmosphere. Now it's about 800. So clearly we're accumulating more and more carbon dioxide in the atmosphere. Now, you might say, well, gosh, it's 400 parts per million. That's a trace gas, right? It is. It's a trace gas in the atmosphere. But why it makes a difference, the so what, the Philistine question is, it's a radiatively important trace gas. Even at trace levels, it makes a difference in the Earth's energy budget. I'll show you. One of the reasons that CO2, even though it's a trace gas and other greenhouse gases, matter is because they absorb at certain bandwidths, certain wavelengths, here, 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 and along in these smaller ones. It's absorbing infrared radiation. That's the heat from the Earth that's coming off of the Earth. And so in the atmosphere, as we build up these greenhouse gases, it's like putting a blanket over the Earth or rolling up the windows of your car in the summertime. It absorbs that back radiation and causes it, anything with more than 2 atoms per molecule is capable of this because it can begin to vibrate. So CO2, as you shine infrared radiation on it, it begins to vibrate. That captures the radiation and causes heat to build up. And that's exactly what's happening. Also, ozone can be important, although it's not a long-term trace gas. And water vapor is very important. More on that later. So, as best as we can tell from measurements and models, the Earth's energy balance is out of whack by about 1 watt per square meter. That may not sound like much because 340 or 342 are coming in from solar radiation. And we've about, well, according to this, 339 are going out. So about 1 watt per square meter. It may not sound like much, but it's enough to begin to warm the Earth and cause some pretty significant changes like melting ice. So the result of that out of whack energy budget is the increase in temperature on average over the whole planet. This isn't really what bothers me, the 0.8 degrees Celsius or 1.4 degree Fahrenheit increase in temperature overall. It's really the variance in that, the extremes that are more troubling. But for areas like the Arctic, it's really quite a lot, maybe 2 or 3 degrees Celsius already causing that. And we think we understand that. It's a positive feedback loop in the parlance of climate change, in that as the Earth first begins to warm, the Arctic ice, which is floating, starts to melt. That white reflective surface yields to a dark sea. The dark sea warms more, melting more ice, which causes the albedo to decrease even more. And it's just a positive feedback loop. And that's why the Arctic is so much warmer than the average here in Iowa of maybe 0.8 degrees Celsius. Now, the clearest signal to the climatologist is this temperature signal in the last, 30-some years, since 1980. The 1980s were warmer than recent history. The 1990s were warmer than that. The 2000s were warmer than that. So we've had a series of a monotonic increase in the global average temperature in recent decades. So I tell my students that you can think of, climate change is the long-term manifestation of our energy balance. Weather is what we talk about today, that it's raining today, but climatologists talk about decade as maybe the single data point. They're interested in decades to centuries to millennia to hundreds of thousands of years, and that's what we're talking about today. So we really have about 3 good data points. 80s were warmer than before, the 90s were warmer than that, and the 2000s were warmer than that. And there's some interest and controversy over this sort of pause, which we've seen in the 2000s. And it is shown here, it's still the warmest decade on record, but we think that's due to an increase in heat in the oceans that has been transferred, which I'll show you in a little bit. Okay, so we know that the carbon is coming from us, and we know that it's a radiatively important trace gas, and we know that it is beginning to warm the Earth. Here's how we know it. First, if you shine infrared radiation onto greenhouse gases, it will get warmer. That's a fact. At one point, it was called the kinetic theory of gases. But that theory has been proven so many times. If you shine that infrared radiation 100 times on the same bag of greenhouse gases, you'll get the same result 100 times. It's a fact that these are radiatively important trace gases. We have satellite measurements of the outgoing long-wave radiation from the top of the atmosphere. We can see that we're missing the spectrum in exactly the wavelengths that I showed you earlier, where it's being absorbed by the greenhouse gases. We're missing those wavelengths. And what's more, we can see since 1970 a decrease in the total energy going out. That's consistent with the fact that you've laid a blanket over the Earth and you're beginning to keep that heat in. Furthermore, we have surface measurements also of the spectra and the amount of radiation coming back down from the absorbed long-wave radiation in the atmosphere. All of these make up the story, this multiple lines of evidence, the compelling story that's consistent with first the atmosphere warms, and it's a top-down warming from there. The result is the changes in this energy results in increasing temperatures. It's not one study. The way science works is you have a hypothesis. And that hypothesis, at the same time, you have alternate hypotheses of what could be causing the same phenomena. And you begin to do experiments, and you reject the alternate hypotheses. And finally, the remaining hypothesis is a proven theory. It's a theory that everybody accepts, like the law of gravitation, that the apple will fall from the tree. Each and every time that it's released by its stem, it'll fall down. And that's what's happened here. We had the original measurements in 2001, followed up by all of these peer-reviewed, published measurements. They don't agree 100%. There's uncertainty in the values, but taken as a whole, the multiple lines of evidence, very, very compelling. When you try to calculate, well, how much radiation could be trapped by these greenhouse gases, this is the latest assessment in the IPCC. It was released in September of 2013 by hundreds of scientists around the world working on it. It's pretty hard to get my colleagues to agree on anything, I must tell you. And to get hundreds of scientists to sign off on these reports is actually very, very difficult. But this is the consensus. And you also can see there's big uncertainty in how much methane is doing, how much black carbon is doing in the atmosphere. The error bars can be large. So yes, there's uncertainty in the estimates, but that uncertainty, again, leads to a conclusion that summed up, some things are causing negative effects on our energy balance, some things are causing positive effects on our energy balance. In net, we've got maybe 1 watt per square meter increase so far. And we're just at the beginning of this thing. We're very early in the story. Remember, only 3 data points so far. It just will continue if we don't begin to curb our emissions. Oftentimes to audiences, I don't even show anything about the models. So far, I've only shown you data, and the data is compelling enough. But I should also mention that another line of evidence is the models. We take everything, first you make a back of the envelope calculation. When things get too complicated for that, you make a spreadsheet. When the spreadsheet will no longer do, you take everything you know about momentum, heat, and mass transfer, and you put it into a computer model. That's the only thing we can do, is to take the best estimates of what we know and make a calculation, and we do it with computer models. When we run the models, here's the rough observations. When you run the models with just volcanoes, sunspot activity, changes in the sunspot, changes in the Earth's elliptical orientation, you get this. When you add the greenhouse gases, the human effects, you can match, with model results, you can match the data pretty well. Without the greenhouse gases, you can't reproduce what's happened in the past. Solar cycles won't explain it, despite what you might have heard. The solar cycles, we get about 0.1 to 0.2% change in the sun's energy. We call it a solar constant, but it's not. It changes. You can see with the 11-year cycle, it's changing here. And it hasn't changed much since the 80s, 90s, 2000s, which I've shown you where the temperatures are going up decade by decade by decade. If you want to go more into the solar cycles, we can do that. But solar correlations with global temperatures simply don't work. With high confidence, then, temperatures are increasing due to human activities. We know this because the warming can be explained by the radiative effect of these gases that we're adding. We know it because we've measured both the outgoing long-wave radiation by satellites. It's consistent with a warming due to the buildup of greenhouse gases. That's satellite data. We've got sensors on the Earth which are measuring the long-wave incoming radiation, which is increasing because of this blanket that's beginning to warming Earth. And the oceans are warming. It can't be explained by any transient phenomena or even ocean circulation. It's very clearly a top-down warming that can only be consistent with a story that first we've added the greenhouse gases, they've begun to warm the atmosphere, and then those in turn have begun to warm the oceans. We can see the signal in the North Atlantic 700 meters down, a diffusive signal of warming from the sea surface all the way down, a very consistent global climate change story. I think it's lost on people that we have a pretty good measurement of how much we're warming. Since 2005, 3,000 Argo sondes or buoys were launched. You can go online right now and see where they're all floating, these 3,000 sondes. And they're giving us a really good picture of all the energy coming in and all the energy going out. If more is coming in than is going out, you can be sure that you're warming. And it's a top-down warming. And so they dive, they're solar powered, they dive down 2,000 meters, and the entire ocean is warming as a result of this climate change. It's a lot of warmth, actually. You know, we said that 0.8 degrees Fahrenheit in the atmosphere maybe doesn't sound like very much, but when you sum it up for the whole oceans, it's about 20 times the primary energy consumption of the entire planet. 20 times. It's quite a legacy that we're leaving for future generations. Here's the sea surface temperatures from NOAA. Just in my lifetime, the last 50 years, sea surface temperatures have increased, when you smear this over the whole planet, about 1 degree Fahrenheit, roughly. Remember, 1.4 degrees Fahrenheit in the atmosphere, 1 degree Fahrenheit in sea surface temperature, top-down phenomena, first caused by the addition of greenhouse gases. What's more, remember I said you would have never convinced me that we could change the oceans in my lifetime? It's not just the radiative effect of these greenhouse gases, it's the sheer chemical effect. We're massively out of balance on the oxidation reduction reactions in the atmosphere. Because when you take something that's been stored for 300 million years and you use oxygen from the atmosphere to combust it right now, you're going to have an excess of oxidating products. Those oxidation products include carbon dioxide. That carbon dioxide is a weak acid. The weak acid is exchanging with the ocean and beginning to acidify the ocean. In my lifetime, the pH of the ocean has changed from about 8.2 to 8.08. Now that may not sound like much, but it's about a 30% increase in acidity just in the last 50 years. That's an amazing change, both in the chemistry and the thermal mass, and quite a legacy we're leaving for future generations. This shows also the increase in CO2, the decrease in pH, consistent with Henry's law, and the gas exchange at the surface where PCO2 is increasing as a result of the carbon dioxide in the atmosphere. You know, there's other effects that we haven't talked about, but I'll go through quickly. Those include very heavy precipitation events. We have satellite data that shows very clearly an increase in high clouds. We have infrared instruments on the Aqua satellite. These infrared instruments can see the increase in humidity. You may have noticed it. Our nights are warmer due to more moisture in the air. It makes sense because as you begin to warm the Earth, there's more, it's a warmer atmosphere. It can hold more water. There's more evaporation from the oceans. More evaporation means more moisture in the air. We see it very clearly with the satellite data. More moisture in the air means more high clouds. More high clouds means more intense precipitation events. Again, a very consistent and compelling story overall. In the Midwest, about a 45%. You experienced it here in Waterloo on Monday night. You know, if you look back in the record at Waterloo, Cedar Falls, it's about a 100-year record. You're very hard-pressed to find a day when you had 4 inches of rain in a single day. I've done it. If you look now, it's really not uncommon to have a 4-inch rainfall here. That's the kind of change in scene. This is the clearest thing in your instrumental record, is the increase in very heavy precipitation events, and it's completely consistent with the climate change story. In Iowa, we've seen an increase in very heavy precipitation. Our days our annual average temperature is warmer, but it's not due to high temperatures. Rather, it's due to warmer nights and because of the humidity. You can see our dew points in the instrumental record just going up and up and up. More and more moisture, again, consistent with the story I'm telling you. We've had about 8 or 9 days of more frost-free. Our winters are a bit milder. More data here. We don't have time to go into it all, but why this is near Oakville, Iowa in 2008 with our floods. As you recall, at University of Iowa, we had 20 buildings flooded. I think 8 condemned by FEMA. We're still trying to come back from it. You had it here in Waterloo as well. This is a 6th Street Railroad Bridge. You may remember in the terrific flooding on the Cedar River as a result of that event. Other effects include the melting of ice. In general, land-based ice globally is melting, including Greenland. This is about half of Lake Erie each year, and it's been increasing. So half of the volume of Lake Erie is being added to the ocean each year as a result of the melting in Greenland. That causes the sea level to rise more precipitously than it has. By the way, sea level rise, we have very good satellite data since 1979. It's accelerated recently because of the melting that I just showed you. Until 1979, it was entirely explained by the expansion, the thermal expansion of ocean water, which gets less dense as you warm it. Now, an important component, almost 50% of it, is due to the land-based ice melting, which I showed. So the end of the story is that we have to respond. I think it's time to respond. You ask yourself the question, when is it more expensive not to act than to act? I think we're at that point now. So yes, we've already experienced climate change, and we need to adapt to what we're going to experience in the future. We're just at the beginning of this thing. But we've got to begin to somehow mitigate our greenhouse gases as well. And I would say let's not wait for government to pass new energy and climate legislation. Let's just find the people who are willing, who understand this, and who are willing to act now, and who believe they can prosper from the changes in our economy that are about to occur as we transition from a fossil fuel age to a new energy economy involving renewables, energy efficiency, yes, maybe even nuclear. We can talk about that. IC in Iowa stresses hyper energy efficiency. This is how we're going to create jobs, wealth, and prosperity in the future. Joseph Schumpeter, the famous economist, talked about creative destruction. We need to wipe out the old and replace it with something better. The fossil fuel age, it's been a good run. We've had more than 200 years where we've created wealth and prosperity based on fossil fuels, but it's got to come to an end. It's not that we're running out of fossil fuels. On the contrary, it's that we're running out of a place to put the exhaust from burning them. And that's why this is how we're going to do it in the future with big wind. We already have 6,000 or 7,000 new jobs in Iowa as a result of wind. Small solar, natural gas maybe as a bridging fuel, and yes, we need a higher price for fossil fuels in order that they become used less and to create economies of scale for energy efficiency and renewables. So, in summary, multiple lines of evidence show that climate change is already here It's caused by humans and by the greenhouse gases that we're emitting. The climate is changing and will continue to change. We're just at the beginning of this. How much risk and damages are we willing to accept? And I would ask, what increase, if you believe this is due to a natural phenomenon, which we do not fully understand, and that climate has always been changing and will always change in the future. If you believe that, I must ask you the question, CO2, in fact, is a radiatively important trace gas. How much are you willing to accept before we begin to act? Thank you very much.
Well, thank you, Dr. Stiliani. Good morning. Great to join you at UNI and CEEE. See if I can get this to work. We've had a great winter, haven't we? Winter of 2014. Good old-fashioned North American winter. There's a great picture of the frozen Great Lakes. Looks like that's going to end. And if you look here, hard to even see Lake Erie. Here's a great picture of frozen Niagara Falls, the Canadian side, the Horseshoe Falls. Last winter was statistically the coldest winter since 1911-1912. Some have said, though, that snow and ice are disappearing. David Archer and Stefan Ramsdorf, in their book, The Climate Crisis, quote, "The Intergovernmental Panel on Climate Change. Snow cover in most continental areas will dramatically decrease unless warming is stopped. Large areas are expected to become snow-free." Funny thing, though, if you look at the actual data from the Rutgers University Global Snow Lab, the North American snow extent has been increasing for the last 40 years. And the Snow Lab reports that Northern Hemisphere snow has also been increasing for the last 40 years. The IPCC has said the increase in temperature in the 20th century is likely to be the largest of any century during the last 1,000 years. So let's put that in perspective a little bit. This is a picture of temperatures in Chicago, my location, for each day of the year from January 1st to December 31st over the last 140 years. This blue line is record cold temperatures. The red is the record high temperatures for each day, and the gray is the max and min temperature average. Now we get a swing of about 100 degrees Fahrenheit on average every year. I'm going to superimpose on that the extent of global temperature change in the last 130 years, and there it is. That change is captured within the thickness of that black line. Folks, that's what all the concern is about. Now, you've probably heard that the Arctic ice is melting, snows of Kilimanjaro are melting, glaciers in Glacier National Park are disappearing. The important thing to remember is that melting is evidence of warming, but not what is causing the warming. Another thing you've probably heard is climate change is real. Some of you have probably used that phrase. Well, that's a true statement. I agree with it, but it's about as profound as grass is green or water is wet. Of course climate change is real. It's not only real, it's continuous. It's been happening for all of human history. Two well-known periods of climate change are the medieval warm period and the Little Ice Age. The medieval warm period was a period from about 900 to 1300 AD, which was about 1 to 2 degrees warmer than the cool periods. The Vikings settled southwest Greenland, formed a colony at Helvasi. They farmed, they raised livestock, they hunted polar bear skins. This was all 600 years before the Jamestown colony. But then, and their settlement grew to about 5,000 by the year 1300. But then the climate cooled and that settlement died out. Now, the historical book of Icelanders, written during that period, says that there were 6-meter trees growing around Helvasi, 20 foot tall. But as you can see, here's the old stone church. All we have today is scrub grasses. About 1300, we entered the colder period of the Little Ice Age. Not a true ice age, but again about 1 to 2 degrees Celsius cooler than either the medieval warm period or today's temperatures. Very tough time for Europe. There were shorter growing seasons. There were famines, population decrease. But they used to have this festival in London every year called the Frost Fair, as this image shows. The Thames River would freeze solid every year, and they'd bring their horses and wagons and sheds right out on the ice and have this festival. Well, you can't do that today. Thames River hasn't frozen solid in over a century. But these are two natural periods of climatic change, nothing to do with man-made emissions, and these have been happening for many, many centuries. Another period was the Roman climate optimum about 2,000 years ago, when the Roman soldiers conquered the Mediterranean in those short skirts. About that time, they were growing olives commercially in central Germany, and grapes were grown in England and harvested to produce wine commercially. If we look at data from ice cores, and we start here, 0 at present day, go back 2, 4, 6, 8, 10,000 years ago to the end of the last ice age, we see 1,500-year cycles. Temperature rises, it falls, it rises. Here's the medieval warm period, here's the Little Ice Age, and here's the modern warm period. Now, one of the things you've probably heard, and our own government has reported it, is that the decade from 2000 to 2010 is the warmest on record. And that sounds alarming, but it's very misleading in terms of the climate. I'm going to show you what on record is. That little green dot on there, that refers to the thermometer record, only 130 years long. So the statement that that decade was the warmest on record ignores all the climate history of cycles and the periods we've had when it was warmer than it is today. Here's an interesting picture of an old white spruce stump located in the Northwest Territory of Canada, up by Alaska, north of the Arctic Circle. It's a very old stump. It's been radiocarbon dated to be 5,000 years old. But the interesting thing about this stump is today it's located 100 kilometers north of the tree line, 100 kilometers north of any other white spruce tree today, indicating that it was warmer 5,000 years ago than it is today. New Jersey Governor Chris Christie has said, climate change is occurring and humans play a contributing role. Well, that's a true statement. I agree with that statement. But again, it's a meaningless statement. Climate is always changing, and my 12-pound dog contributes to climate change. The real answer is what is the size of the human contribution? Earth's climate is complex. It's shaped by powerful forces from the solar system, the oceans, the atmosphere, and the land. Sunlight falls directly on the equator and the tropics, and much energy is absorbed. It falls indirectly on the polar regions. All weather on Earth is driven by this redistribution of heat from the tropics to the poles. Storm fronts, hurricanes, jet streams, ocean currents, all driven by this solar activity. The oceans are powerful forces shaping Earth's climate. The oceans have 250 times the mass of the atmosphere and can hold 1,000 times the heat. And then we have emissions, aerosols from volcanoes, desert dust, pollen from plants on land and from the ocean that shape the climate. Yet today's climate scientists are obsessed with the atmospheric level of carbon dioxide, a very, very small part of the overall picture. As a matter of fact, carbon dioxide is a trace gas. To get an idea how small, picture a basketball arena filled with fans, 10,000 fans. Only 4 of every 10,000 molecules in the atmosphere are carbon dioxide, And the amount that human industry could have added in all of our history is only a fraction of one of those 10,000 molecules. Now, I think you should have learned from Dr. Schnorr's presentation, what is nature's most abundant greenhouse gas? Anyone? Absolutely right, it's water vapor. It's not carbon dioxide, it's not methane, it's water vapor. Scientists generally agree that somewhere between 75 and 90% of Earth's greenhouse effect is caused by water vapor and clouds. So if we're conservative and say 3/4 of Earth's greenhouse effect is due to water vapor and clouds, then the last quarter is due to carbon dioxide, methane, and other gases. But then we need to ask, well, how much of this last quarter is due to man-made emissions? Because the oceans hold 50 times as much carbon dioxide dissolved as the atmosphere. And the oceans are always releasing carbon dioxide and absorbing it. When plants die, they release carbon dioxide. When they grow, carbon dioxide is absorbed. Every day, nature puts 25 times as much carbon dioxide into the atmosphere as all of the industries of man. So when we roll all that together, that means man is responsible for about 1 part in 100 of Earth's greenhouse effect. 1 part in 100. If we completely eliminated all emissions, we probably could not measure the difference in global temperatures. Now, physicists also generally agree that carbon dioxide by itself cannot cause dangerous warming. That's because the absorption spectrum of carbon dioxide is nonlinear. The first carbon dioxide in the atmosphere absorbs a lot of infrared radiation and raises temperatures. But as you put more and more CO2 in the atmosphere, you get less and less of an effect. So we're all the way out here right now. And if we double, either from human emissions or natural emissions, the amount of carbon dioxide in the atmosphere, we will only raise global temperatures about 1 degree Celsius. We'd have to double it all again to get another degree. So how do climate scientists get their alarming projections of 3 and 4 and 5 degrees Celsius rise? Well, the answer is a thing called positive feedback. All of the models assume that as we put carbon dioxide into the atmosphere, we cause the atmosphere to warm a little bit, then the atmosphere holds more water vapor, which is a greenhouse gas, further raising global temperatures. But a number of papers indicate that this positive feedback is not occurring, and that the effect of clouds may actually reduce the effects of carbon dioxide warming. Matter of fact, now I call this the flea wagging the dog theory. When you think that man's tiny addition to a trace gas is actually controlling or influencing Earth's water cycle, which is huge, powerful. Water cycle includes all weather on Earth, the effects of all ice caps, the effect of oceans. Really, in some ways, that's a preposterous flea wagging the dog theory. Now, if movie detective Dirty Harry were a climate scientist, he'd probably say, your climate models ain't making it. And indeed, according to the Intergovernmental Panel on Climate Change, they call this a signature. They said in the atmosphere we would see a temperature hotspot. All of the models predict this. View this as a map of the atmosphere, and this line, the surface of the Earth, 90N is the North Pole, EQ the equator, 90S the South Pole. All of the models say if we go up into the atmosphere about 10 kilometers, and we go over the equator and the tropics, we will see a temperature hotspot, an area that warms faster than either the rest of the atmosphere or the surface of the Earth. But what do 7 satellite and weather balloon data sets show? They show this, no hotspot found. This is what the models predict. This is what the actual data shows. Now, 2 scientific panels have been convened, and more than 300 papers have been written to try and explain why the models don't match the measured data. And the proponents of the theory of man-made warming say, well, the data must be wrong and the models must be right. But this is powerful evidence that we're not seeing catastrophic warming. And indeed, for the last 17 years, we've had flat global temperatures. Actual temperature measures are shown by these two satellite data sets here, the red and the blue. All of the world's climate models are wrong. They all predicted a much faster rise in temperatures. Those are all the model lines here. This black is the averages, and we're not seeing, the data is not supporting the theory of man-made warming. So what caused the late 20th century warming? Well, if you look at temperature and carbon dioxide, you see that CO2 doesn't really track temperature very well. CO2 has been generally rising for the last 50 or 60 years. These are seasonal variations. We've had flat temperatures since about 1997, and actually a slight temperature decline since about 2002. Here's the warming everybody's been concerned about from 1975 to 2002. But from about 1940 to 1975, we actually had a cooling in global temperatures. And that led to the Ice Age scare in the 1970s that maybe some of you remember. Time and a lot of the scientific journals, Newsweek, were predicting we were moving into an ice age. Well, to get an idea what's causing this situation, we got to think of that small global feature called the Pacific Ocean right off the coast of California. 1/3 of the Earth's surface area. Turns out the Pacific Ocean has natural temperature cycles all by itself, and these are measured by what they call now the Pacific Decadal Oscillation. And you see here, this is a temperature variation in the Pacific, 1 to 2 degrees. Temperatures rose from about 1910 to 1940, then they cooled about 1975, rose again to about 2000, and now we've moved into a cool phase again. Scientists estimate this cycle's been going on for thousands of years, nothing to do with man-made warming. And it's only one of many temperature cycles of Earth. We have an Atlantic multi-decadal oscillation. We have many other cycles that occur all the time. So now we can explain the 20th century rise. And it's a combination of the long-term rise since the Little Ice Age. We've been coming out of a natural warming for about the last 400 years, and then superimposed on that the short-term variation of Earth's natural cycles, like the Pacific Decadal Oscillation. Dr. Sianishi Akasofu says it's quite obvious that the temperature change during the last 100 years or so includes significant natural changes. It's very puzzling that IPCC reports state that it is mostly due to the greenhouse effect. We need absolutely no connection with carbon dioxide to explain the natural changes of the last century. But what about sea level rise? Former Vice President Al Gore and Dr. Hansen, James Hansen, have warned of a 20-foot rise by the year 2100. If that were to occur, that would certainly be a disaster. These areas of Florida would be flooded. Many other ports around the world would also be impacted. So we need to look at Earth's 3 ice caps to talk about sea level rise. The first is the Arctic ice cap. It is true that Arctic ice has been declining for about 30 years, with lows about 2007 and more recently 2012. This is satellite data. A couple things you need to know about Arctic ice. First, Arctic ice naturally comes and goes. There have been historical records of periods in the past when it has been low, as it is now. But second, now this is called the canary in the coal mine by many climate scientists, saying that our industries must be causing global warming. This is only 1 to 2% of Earth's ice. So if we really need to see what's going on, we need to look at the elephant, and the elephant is South Pole ice. Not more than 2 weeks after we reached a 2007 low in Arctic ice, we reached a 2007 high in Antarctic ice. Antarctic ice has been increasing for the last 30 years. Antarctic ice is 90% of Earth's ice. The models can't explain this. The models predict that this ice would be disappearing as well. And let's consider the Amundsen-Scott South Pole Station. The United States has maintained a continuous scientific presence at the South Pole since the 1950s. Does anyone know, and this is the third scientific station down there, anyone know what happened to the previous two stations? They got buried by snow and ice. Antarctic is a desert, but every year it gets about 8 net inches of snow, 8 inches the next year, 8 inches the next year, 8 inches the next year. It gets to be a problem. And you can see the second station right here with the snow all up around the sides. Well, on this station, what they did was they built it in 7 modules, and they put it on stilts. So this station can be jacked up every year over accumulating snow, and it prolongs the life of the station. Folks, this is 90% of Earth's ice, and it's getting thicker. And then Dr. Schnorr and I just love this picture of this Mulan. And you see this on PBS with the water pouring into a crevasse. Interesting thing about Greenland is it's located in an area where it freezes every winter and it has a huge melt every summer. This has been going on for centuries and centuries, and so you get pictures of this water pouring down. This is nothing new, been happening for a long time. I call your attention to the story of the P-38 Glacier Girl, and you can look this up online. 1942, 8 planes took off from the United States to fly to England by way of Greenland and Iceland, take part in the war. They got caught in a storm outside Greenland. They were forced to turn around and crash land on the surface of the ice. The Coast Guard rescued the pilots and crew. 40-some years later, expeditions were mounted to go back and find the planes, but they couldn't find them. The 4th expedition went back with sophisticated subsurface radar and found the planes immediately. And this is a picture of the P-38 Glacier Girl in an ice cave. And this plane was found under 268 feet of ice. They tunneled down, they took it apart, and it's flown in air shows. But the interesting thing from a climate point of view is from 1942 to 1992, 50 years, 268 feet of ice accumulated on top of these planes on the melting ice cap of Greenland. In fact, the ice cap is melting near the edges, it's getting thicker in the center, and it is not in any danger of melting away soon. So what does this mean for global sea level rise? Well, NASA will tell us that ocean levels have risen about 120 meters or 390 feet since the last ice age. No scientist can tell you when natural ocean rise stopped and man-made ocean rise started. But tide gauges show us that we've seen a rise of about 7 to 8 inches per century, about 1 millimeter a year over the last 150 years. So it's unlikely we're going to see a catastrophic rise in the near future. Aren't natural disasters evidence of man-made climate change? Well, folks, floods are nothing new. I want to take you back to the Great California Flood of 1861-1862, when rains for 8 weeks in December and January came in off the Pacific Ocean, dumping water on the state. It's a picture of K Street in Sacramento, where the water got to be 10 foot deep. The governor had to take a rowboat from his house to the Capitol building to be sworn in. Then he promptly canceled the government and moved it to San Francisco until the water went down. Down in Los Angeles, they received 60 inches of rain in just 3 months. Normally they get 10 inches. Can you imagine what they'd say today if that happened? They had lakes around Anaheim. They had parts of the Mojave Desert looked like an ocean. But the biggest impact was in the Central Valley of California. William Brewer toured that in January of 1862, and he said, thousands of farms are entirely underwater. In the Sacramento Valley, for some distances, the tops of the poles are underwater. He meant the 20-foot-high telegraph poles. The entire valley was a lake extending from the mountains on one side to the Coast Range hills on the other. Nearly every house and farm over this immense region is gone. At that time, California had 800,000 cattle, and 200,000 of them died in this disaster. So this shows you the power of what natural effects can do. Here's a great picture of Hurricane Sandy off the east coast of the United States. Interesting storm, heading out in the North Atlantic, hit a high-pressure area, came back and made a direct hit on New York City. It hit at high tide, and it also ran into a storm front that was coming from the west at the time. Many have said that this is evidence of man-made climate change. But this has happened before. Recall the Norfolk and Long Island hurricane of 1821. Actually, I'm not old enough to recall it, but it came busting right up the East Coast. When it hit New Jersey, it was Category 3 or 4 hurricane, much stronger wind speed than Hurricane Sandy, and it struck New York City at low tide. The ocean levels were 5 foot lower than when Sandy hit, yet it still flooded 1/3 of Manhattan Island up to Canal Street. During the 20th century, we had 170 hurricanes make landfall in the United States. 59 of those were Category 3 or stronger, all of those stronger than Hurricane Sandy. So how does it then become evidence that one hurricane that makes a direct hit on New York City is evidence that a trace gas is changing our climate? And if you look across the globe, from satellite data at the number of tropical storms, the number of hurricanes, you see no change over the last 40 years. Scientists can also look down and measure the wind speed for every hour that a storm is in existence, and they put together a metric called the accumulated cyclone energy. We've had some high periods in the past, but Dr. Ryan Maui was able to report a couple years ago that we were at more than a 30-year low in terms of accumulated cyclone energy. As a matter of fact, we're in the middle of a hurricane drought right now in the United States. We've not had a Category 3 hurricane make landfall in the United States for more than 3,000 days, 8 years. That has never happened in the weather record. Typically, a Category 3 makes landfall every other year. Same thing for tornadoes. Back when the Pacific Decadal Oscillation was in a cool phase, up until about 1975, we had a lot of tornadoes, across the U.S. When we had the warm PDO phase from 75 to 2000, not many tornadoes, statistically. But folks, guess what? Bad news, the PDO has just gone cold, so we're likely to see a rise in tornadoes in the United States. I've had the joy of kayaking many of the great whitewater rivers of North America over the last 30 years. We all want clean air and water, don't we? But our air today is very, very much cleaner, according to data from the EPA. Ozone, carbon monoxide, nitrous oxides, sulfur oxides, leads, carbon particulates, all dramatically down. Even though we're getting 30% more electricity from coal-fired power plants, and we're driving twice the vehicle miles. Yet some are now calling carbon dioxide a pollutant. Sadly, the news media is doing that, and even the Environmental Protection Agency. Ladies and gentlemen of you and I, that is bizarre. Carbon dioxide is not a pollutant. It's an odorless, harmless, invisible gas, does not cause smoke, does not cause smog. We breathe in only a trace of carbon dioxide with every breath, but as we burn sugars in our bodies, we create carbon dioxide, and so we breathe out 100 times what's in the atmosphere with every breath. Matter of fact, CO2 is green. CO2 is plant food. It's essential for life on Earth. Hundreds of peer-reviewed studies show that increased levels of atmospheric carbon dioxide increases plant growth. Wheat, oranges, orange trees, young pine trees. Even poison ivy grows bigger and faster with higher levels of atmospheric carbon dioxide. Plants get bigger root systems. They're more resistant to drought. They get bigger fruits. They get bigger vegetables. They get thicker tree trunks. If there's one compound we could put into the atmosphere that would be great for the biosphere, carbon dioxide is that compound. But don't 97% of scientists accept the theory of man-made climate change? Well, even the president has made this statement now. It's been all over the press. The original study this came from was a study by Doran and Zimmerman in 2009. They sent out a survey to 10,000 members of the American Geophysical Union, and they asked two questions. One, when compared with pre-1800 levels, do you think that mean global temperatures have generally risen, fallen, or remained relatively constant? Well, I would say risen. Anyone who knows the history knows that. We've been coming out of the Little Ice Age for the last 400 years. And the second one, do you think human activity is a significant contributing factor in changing mean global temperatures? They didn't say, is it the primary change in climate? Is it a dangerous thing? From that, they got 3,000 responses, and then they said, well, let's decide who's a bona fide climate scientist and who isn't. So they chose 77 out of that, and 75 of those folks said rising, and we think it's significant. So folks, this is the opinion of 75 people that 97% of, that quote, 97% of scientists. Another study by the American Meteorological Society, just in 2013, of 1,800 responders, 52% said global warming is happening and humans are the cause. So I will grant you, this is what I'm doing today as a minority report, I would grant you that the majority of scientists do think humans are causing climate change, but the level is not 97%. The bottom line here, IPCC forecast in 1990, they forecasted an increase in global mean temperature during the next century of about 0.3 degrees C per decade, with an uncertainty range of 0.2 to 0.5 C per decade. I'm almost done, one more slide. Here's the plot of their predictions. There's their best estimate, high and low. Here we are today in actual temperatures, far below the IPCC projections. We are not seeing catastrophic climate change according to the evidence. So in summary, climate change is a natural effect. The greenhouse effect is overwhelmingly a natural effect. Mankind is responsible for only about 1 part in 100. And it's been a pleasure to talk to you today. Thanks very much to Dr. Catherine Zeman for the opportunity to speak, and I look forward to your questions and challenges.
Okay, so now we're in the question and answer period, and again, the rules are each person will have about 2 to 3 minutes. If you go to 3 minutes, I'll probably cut you off just to make more time. No insult intended. But also, in case there's something that you really think is important to say, we're going to leave a few minutes for you at the end, so that you'll have an opportunity to do so. And I'm going to start. Actually, let me scroll the screen a little.
So what did you say, how long do we respond to each question?
3 minutes.
3 minutes, okay.
I stopped talking there. So I'm going to start. I've got 2 questions, one to each speaker. And so we'll start with letting that speaker address that question, and then the other person can address it in response. So the first one to Dr. Schnorr. Am I pronouncing your name right?
Yes.
Okay. How do you reconcile the validity of the IPPS's climate computer models when it's been shown they violate 70 to 89% of applicable principles of forecasting? Now,
I'm sorry, I didn't catch that question.
That's the claim.
I'm having trouble with your microphone. Can you read it again? I didn't understand what you said.
Let me pull back a little bit from it too, that might help. Okay? How do you reconcile the validity of the IPPS's climate change models?
IPPC.
Sorry, okay. When it has been shown they violate 70 to 89% of applicable principles of forecasting?
I don't know how to respond to that question because it's not clear to me what's answered, but what's being asked. But I would say that these models, we were just talking about it with the gentleman in the third row. There's 20 different models that we're tracking. They're all over the world from different groups. All 20 of these models, so again, when you make a back of the envelope calculation, then you make a spreadsheet calculation. When that gets too complicated, you take all that you know and you put it into a model. That's what's been done. These are very sophisticated, complicated numerical computer models. 20 different groups all around the world are being analyzed by the IPCC. Those 20 groups disagree. They disagree, and the error bars are significant and shown on some of the slides that I showed. But all 20 say it's going to be a warmer 21st century. They've taken the first principles of momentum, heat, and mass transfer, put it into the models, and all 20 agree that in the direction, not necessarily in the amount. And the amount is important, as Steve said. That's what we call the climate sensitivity factor. But they all agree. That should give you some pause right there. When 20 different groups, thousands of publications, they all agree that this is a serious problem, and it's being driven mostly by greenhouse gases emitted by us.
Dr. Gorman, do you want to respond?
Sure, I'm not a doctor, thanks for the promotion. I would just say they all agree, but they're all wrong. They've all been wrong in the wrong direction. By the way, funding is a messy thing to discuss, but I wonder which of those climate models would get any funding if they said, gee, I think climate change is natural. Guess what? You don't get any more funding to do your climate study. So there's a bias there within those model teams, I'm sorry to say.
Okay, the next one was, am I off now? Can you hear me? Are you here? Can you hear me now? Okay. The next one was to Dr. Gorman. You indicated that the human contribution of CO2 is too small to be a factor in climate change. But the data shown by Dr. Schnorr correlates CO2 from the human observable changes in temperature, acidity, etc. So how do you explain this?
Well, again, correlation is not causation. We've had many, many periods in the past when it's been warmer. It is true, as I understand it, that humans can influence climate on a local scale. We can certainly build cities and airports, and we see an effect called an urban heat island effect, where temperatures actually rise just because there's more human activity, there's more cement, there's more cars. But on a global scale, it does not appear that that is the case. And again, melting is not evidence of what is causing the melting. It just, it could be natural situations just as much as man's addition to atmospheric carbon dioxide.
Thank you, Dr. Schnorr.
Again, the models contain the basic principles of momentum, heat, and mass transfer, the basic principles of physics, which have been proven throughout time. They are the best estimate that we have. That's all we can do, especially if you want to make an estimate of the future. You have to take all your knowledge, the best estimates that you have, and put them into a model and try to make a forecast. It's not a correlation, as the question implied. What I'm showing is a causation. It's a causation because greenhouse gases are radiatively important gases. They absorb, it's a fact. If you do the experiment 100 times, they will for 100 times absorb back radiation. And what's more, it's confirmed by the satellite measurements showing missing those spectrum that exactly are being absorbed in the up radiation to space and more radiation going down to Earth. Completely consistent with the calculation in the models of how much warming should occur. So that's what I'm talking about, the complete science story. I am a little frustrated by Mr. Gorham's slides because most of the references in the bottom, when I read his book, I can't look them up. They're not scientifically peer-reviewed publications. The way the scientific method works is you put a hypothesis out there and everybody shoots at it. And you shoot at it time and time and time again. And when the hypothesis, all the alternative hypotheses are rejected, the remaining one stays. And that's that greenhouse gases are causing the warming that we're experiencing. His references are anecdotal at best, not peer-reviewed, and have very little credibility with the scientific community.
Now, with that last comment, I should give Dr. Gorman a chance to
I have about
respond.
800 references in my book. About 75 of them are from peer-reviewed papers. There's about 100 to 150 from government organizations or the IPCC. I would just point out one thing here. The radiation changes could be due to changes in cloud cover on the Earth's surface. And there are a number of studies that show that that may be the case. Changing cloud cover may be the reason for recent warming. It doesn't have to be carbon dioxide. That is an assumption, and the models are based on an assumed impact from carbon dioxide.
What
So
causes the change in cloud cover?
Well, there's solar effects that could do those. There are many, many
We're
effects.
monitoring the solar effects. Cosmic flux. We monitor that very closely, including the Del 14.
I talk about that in Chapter 5.
C14.
So let me pause and go on to the next question. This one's, I think, going to be a fun one, but it also does get at something I think people wonder about. So if the positive and either one of you can start on this one. If the positive feedback of CO2 leads to runaway warming, that's that positive feedback loop, why didn't the Earth end up like Venus during the Carniferous period? And if the negative feedback ends up trumping the positives, do the IPCC models put sufficient weight on negative feedback mechanisms?
I'm having trouble with the questions. I can't hear you.
Okay.
It's probably where we're sitting here. But
Yeah.
Basically, they're asking,
Just speak.
it would take too long to scoot that up there. So basically, if the positive feedback of CO2 leads to runaway warming, why didn't the Earth end up like Venus during the Carniferous period? It's the main question. And then if the negative feedback loops end up trumping the positive, are those being taken into account in the current models?
The negative feedback, we were just talking about this too. The negative feedbacks are taken account of in the models, and they're not enough to overpower the positive feedbacks that you're speaking about. The first part of the question was,
So why didn't we end up like Venus during the
well,
Carniferous
if we kept going with CO2, it doesn't stop. You know, we would become Venus. That's what I think is lost on the public, because so often we talk about the changes to 2050 or 2100. They somehow think it magically stops if we don't decrease our emissions, and that's simply not the case. It just goes on and on and on. That's why my last question for the group was, when do you agree with radiatively important trace gases? When do we begin to stop? At what level? It's up to you.
So
the first part of the question still.
yeah, I think the question refers to a period back in distant Earth history, hundreds of millions of years ago, when atmospheric carbon dioxide levels were much higher. At that time, many geologists would say that they were 3,000 or 4,000 parts per million in the atmosphere, maybe 10 times as high as they are today. So there is some evidence that, matter of fact, Dr. William Happer of Princeton says that we are in a low spot in history in terms of atmospheric carbon dioxide level, 300 or 400 parts per million, fairly low level. Plants are actually starved for carbon dioxide at about 250 parts per million. So I'm in favor of this carbon dioxide. Again, if we are not getting positive feedback from water vapor, we double carbon dioxide to 560 degrees, to 500 parts per million, we'll see about a 1 degree rise in atmospheric carbon dioxide, and much of that has already occurred if it's only due to CO2.
For all practical purposes, we are at a high point in carbon dioxide that we haven't seen for thousands of years. 30 or 40 million years ago, even the continents were in a different place. The energy balance of the Earth was much different. And yes, we had higher carbon dioxide content. You don't want to go to that place again. We're talking about modern history here, and we can explain, based on the increase in carbon dioxide, the warming that we've seen. But the second shoe hasn't dropped. We've never done this experiment before that we're doing with planet Earth. Always before, the energy balance changed, and that released the CO2 after a temperature change. We've reversed the experiment. We've first released the radiatively important trace gas to unprecedented levels, and now we're waiting for the second shoe to drop, the warming that's going to follow it.
Thank you. So just a practical question, right, from a lot of people. What does climate change models tell us about our capacity to change the trajectory of climate change? I.e., can we really make a big difference, a significant difference, by switching to other forms of energy?
Do you do that first or do I?
Whatever you like.
Who's first on that one? Who should go?
Well, I think this is more addressed
Okay.
to you because you don't think it's necessary.
I think it'll be difficult, but I think it still can be done. Basically, we need to level off our emissions, global emissions, the curve I showed you, by 2020, and have maybe a 50% reduction by 2050, and further reductions after that, maybe 80 or 90% reduction. I was born in 1950. We need to turn back the clock to the amount of emissions we had in 1950. And that leads me to say that we have to have a complete transition from the fossil fuel age. So yes, it can be done. We can, I think, protect the earth with actions, prudent actions today, and I think we can prosper from it, as I said, but it will, I admit, it will be difficult.
Well, I would like to answer, though. As you say, I don't think this is a problem, but sometimes I do put up a chart. The current administration has a goal of reducing 83%, or emissions by 83% by 2050 from 2005 levels. If you go back to that emissions level, you actually have to go back to 1870 if you include population growth, expected population growth to the United States by 2050. Back to 1870, that's the emission level of Nigeria today. There are only three of every 100 people in Nigeria have a car, and about 40 to 50% of Nigerians don't have access to electricity. There is neither President Obama nor any other world leader knows how to get to that kind of a level of emissions drop. So the good news, though, is carbon dioxide helps plants grow, and et cetera.
Okay, so both of you have said that, well, actually not quite. One of the questions was, what accounts for the difference between Steve's claim that U.S. CO2 gas is down and Jerry's claim that CO2 gas is up?
You never claimed it was done.
Well, I didn't claim it was
No.
down.
No.
I just claimed it's not causing dangerous climate change. So.
Okay. They might also be thinking about the weather claims there, too.
There is absolutely, with the exception of what Dr. Schnorr mentioned, that we have seen a little more rainfall in some spots. But if you look at data from the National Climatic Data Center, you go back 100 years and you do the percent of the United States that's either dry or the percent of the United States that's wet. Sometimes I put those curves up, not enough time in 30 minutes. There is no evidence that we're seeing either more dry or more wet periods, more tornadoes, more hurricanes. There is no evidence to support any of those either in the United States or globally.
Tornadoes and hurricanes are more iffy. I agree with Steve on that. The data is not clear yet. And there's even reasons that warming should decrease hurricanes in the tropical regions, and which are shown in the model as well. But clearly, again, the most significant thing in the record, nationwide, I showed you the data from the National Oceanic and Atmospheric Administration, is that we're having much more severe precipitation events right here in Waterloo. And it's a big concern, as you know. We're getting 100-year flood this year. 2 years later, we're getting a 200-year flood. How many of these can we have? It's caused by, and the models mostly get this right, and satellite data shows that we have more moisture in the air. It's very clear since 1979 that there's more moisture in the air and there's more high clouds. And those high clouds are what causes the severe and intense precipitation events, all consistent with the climate change story that I tried to lay out.
Now, some of the other questions were too technical, I think, for certainly me and our audience. But here's a general question that some people basically asked. They wanted to hear each of you say what you wanted to respond to most from the other person's talk. So what is it that you would like to respond to most in terms of what the other speaker said? And who would like to go first?
I think the temperature chart, it's hard because we can't go to the exact slide,
Yeah.
but the temperature chart, basically global temperatures have been rather constant for the last 8,000 years. And Steve showed one where, which was never published, where the medieval warming period was greater than the current warming. That's simply not true. The little ice age does show up in fossil records, tree core, tree rings, and ice cores. And the little ice age we think was caused by the so-called Maunder minimum. less sunspots, less energy coming from the sun, very unusually so during that period. And yes, the Thames froze and the canals froze and Hans Brinker and the Silver Skates, and we think we understand why. The medieval warming period is a bit more complicated. It was not as warm as it currently is today, right now. He's wrong about that, and the graph he showed is wrong and not peer-reviewed. But the medieval warm period was very warm. That's when the Vikings came over and discovered North America. We think it was a European warming primarily and not a global warming. Other areas were cooler, so that was not a global phenomena. Exactly what caused it is the subject of many, many studies, and it's not entirely clear what caused the medieval warm period 1,000 years ago.
I'd like to respond to that. Oh, I know you. So you can all go to a site called co2science.org. On that site, there are several hundred peer-reviewed papers. There are more than 100 papers on the medieval warm period. These are peer-reviewed papers, and they're from all over the world, not just North America. They're from South Africa. They're from the ocean near New Guinea. And you can take 100 of those papers, and 80 of them, there are about 100 papers that allow a numeric comparison between temperatures during the medieval warm period and today's temperatures. By the way, these are from ice cores, they're from forest fires, they're from C14 isotope concentration in cave stalactites. There are all sorts of different proxies. 80% of those show that the medieval warm period was warmer than today's temperatures. And so, again, go to CO2 Science and you will see that evidence. Do you want one last comment?
Well, I would just say that even if the medieval warm period, even if what we're experiencing now is due to some kind of natural cycle that we don't understand, even if that's true, it should still give you pause. It should not give you any comfort because of the fact that the greenhouse gases that we're adding to the atmosphere would be warming the earth over and above that natural cycle. It should make you want to act even more.
So Dr. Gorman, is there a place that you want to respond to, particularly from earlier?
One curve struck me that is one of the IPCC curves that Dr. Schnorr put up, and that was the one that showed the models where they were warming and they tracked temperatures, and then when you removed the man-made influences, they didn't track the temperatures. I hope you all know that that's basically bunk. Those computer models are tuned, their coefficients are chosen to track global temperatures. They're physically chosen and run to track temperatures. And then if you base it on key variables, carbon dioxide and methane, and then you remove those variables, obviously the model will no longer track temperature. I mean, that's a freshman operations science course. So yet that's put in the IPCC of evidence that the models are right. It's just very, very foolish logic.
Well, that particular graph, as a modeler, I can say it's because the models have a lot of parameters, it's true, and they need to be tuned. They tune them with the data. So it's very difficult to match the temperature record given all the other parameters, including the radiatively important trace gases, without including those. You can't, it's very difficult to tune the model to get the, without putting in the greenhouse gases, you can't reproduce the temperature record. It's very difficult.
So I think we have time for one more question, and so there's one in here which I think is also interesting. The example of the airplane in Greenland is quite dramatic, and yet the question that came up was, first of all, glaciers move, they have compression below, things feed off, and snow comes down. Isn't the main issue is not whether it's at that depth, but what the total depth is of the ice at Greenland, what the total amount is. And so could you address, is the actual total amount of ice in Greenland, what's going on with that?
Well, I would agree that the ice in Greenland is declining somewhat. It's a very small amount. If you plot out the actual loss and you put it on a curve, you can see absolutely none versus the total ice loss. Temperatures were actually warmer in Greenland, according to a number of thermometer gauges in the 1930s, though. So I agree there's slight loss in Greenland ice, but folks, we're in a warming period for the last 400 years, so we're going to have some ice loss. That's a natural factor.
The difficulty with Steve's data that he showed is much of it is anecdotal. It's at one place in time, one place in location. What I'm talking about is a complete global calculation. And what that calculation shows is that we have satellites which do gravimetric analysis. We know the mass of the ice on Greenland quite accurately. We know the mass of from space, the mass of the ice in Antarctic quite accurately. 20 papers, all fussing with each other about the second decimal point. In fact, we are losing ice both places. We're losing ice off the ice shelves of western Antarctica, even though it is building up in the middle, as he said, and we are losing ice massively from Greenland. Because of that, the big story in the last 10 years has been the change in the rise of sea level from the 1 millimeter that Steve mentioned to now 3 millimeters per year. That increase is due to the meltwater, which we're very accurately tracking from space, making a global calculation with many, many people contributing.
Do I have 45 seconds on that? Folks, I don't know if you know how much that is, but sometimes my presentations I put on the table a quarter, and then I put a dime, and I go, the quarter is the historical average sea level rise per year, averaged across all the oceans. And this dime is the average acceleration, the thickness of a quarter and a dime. Now, anybody think we can measure that across all the oceans of the world? I could go into all the errors in that analysis, but the human adjustments are a couple orders of magnitude bigger than the actual measured data to come up with that analysis, and there's a whole lot of holes in that sort of thing. Nobody would be doing that if it wasn't the theory of man-made warming. The only thing that's important is if you're on the edge of the ocean, what is the ocean and the tide gauge doing at your location?
Well, thank you very much. This was very enlightening. That was what I was kind of offering you. Okay,
do you want to do 3 minutes?
I thought I gave that to you when I gave that last question, and would you like to respond to them?
No, I got 3 minutes.
But if you want 3 more minutes, can we take the time?
You want me to go first?
Okay.
Please.
You can have 3 more minutes for a closing statement then.
So, there are many important problems to solve in the world today. According to the United Nations data, 20,000 people die each day from hunger-related causes. 2 billion people are trying to survive on, did I say 20 million? 20,000 people die each day from hunger-related causes. 2 billion people are trying to survive on less than $2 a day. 1.8 billion don't have proper sanitation. 1.4 billion don't have electricity. Almost 1 billion people don't have proper access to clean water. And millions die each year from disease, from malaria, tuberculosis, AIDS, and diarrheal diseases. Yet the world is spending over $250 billion a year to try and stop the planet from warming. I submit to you that is misguided, that we should be taking that money and solving the real environmental, pollution, and poverty problems of the world and stop this futile effort to solve a problem with global warming. Because the greenhouse effect is overwhelmingly natural, and because climate change is overwhelmingly natural, there is no regulation that the EPA can pass that will have a measurable effect on hurricanes and storms. There's no law that Congress can pass that will affect the droughts and the floods. Thousands of regulations in hundreds of nations, all summed together, are not going to have a measurable effect on Earth's temperatures. So let's get on and solve the real problems of the world.
It's a false dichotomy to represent that the transition from the fossil fuel age to something new and better is an either-or choice. We don't have to address world poverty. We don't have to ignore climate change in order to address world poverty. We can do both at the same time. In fact, we can do it and prosper. It is the way to the engine for economic growth in the future, much like we've done in Iowa. Windmills creating jobs for 6,000 or 7,000 people. Energy efficiency creating jobs for people who weatherize homes. Changes in infrastructure, which we should be improving anyway as a result of adapting to climate change. We can do all these things and prosper the economy if we have the resolve. And I'm convinced that we can and we will. What's more, not only will we improve climate change, but we will also improve our health. We'll have cleaner air by transitioning out of using coal for the fossil fuel age, and we will have less health care costs, less missed days of work, and many, many advantages. 100 years from now, we'll look back on this time as, oh my God, they were Neanderthals. What were they doing? Mining all the fossil fuels that had accumulated for millions of years and trying to burn them up in the blink of an eye and gassing themselves in the meantime. We're going to a better place. It's going to allow us to create a better economy. It'll be the engine for economic growth and jobs for the young people I see in the audience. This is something we must do.